Hello everyone, welcome back to my YouTube channel. Myself Chaitanya BS, 5th SEM, Electronics and Communication Department. Today I am here to explain about the role of modulation techniques in the evolution of wireless communication from G1 to G5. In this slide, we can see the introduction part. The evolution of wireless communication from G1 to G5 has been influenced significantly by advancements in modulation techniques. Modulation techniques plays a crucial role in encoding data onto carrier signals for efficient transmission over wireless networks. As wireless technologies progressed, modulation techniques have evolved to meet the increasing demands for higher data rates and improved spectral efficiency. These in this picture we can see the four types of generations. First generation wireless network is basic voice services and analog based protocols. In the second generation wireless network, designed for voice, improved for coverage and capacity, first digital standards. In the third generation wireless network, designed for voice with the same data consideration, multimedia, text, internet. First mobile broadband. And the fourth generation wireless network, designed primarily for data, IP based protocols, true mobile broadband in these generations. And the next is modulation techniques in 1G. In 1G systems, analog modulation techniques such as FM stands for frequency modulation, were predominantly used for voice communication. Frequency modulation allowed for the transmission of voice signals over limited bandwidths, enabling basic wireless connectivity. However, the analog nature of frequency modulation limited the data rates and spectral efficiency achievable in 1G networks. In this picture, we can see the types of modulation. There are two types of modulation. One is analog modulation and another one is digital modulation. In the analog modulation, there are three types of modulations: amplitude modulation, frequency modulation, and phase modulation. In the digital modulation, there is also three types of modulations. One is amplitude shift keying, frequency shift keying, and phase shift keying. These are the types of digital modulations. And here we can see the transition to digital modulation in 2G. The transition to 2G networks marked a shift towards digital modulation techniques like GMSK. GMSK stands for Gaussian Minimum Shift Keying, and the QPSK. QPSK stands for Quadrature Phase Shift Keying. Digital modulation offered improved data rates, spectral efficiency, and error correction capabilities compared to analog modulation is used in 1G. The adaptation of digital modulation in 2G paved the way for more advanced wireless services such as SMS and data transmission. In this picture, the types of digital communication techniques is one is coherent and another one is non-coherent. Coherent means in coherent modulation technique, process received signal with a local carrier of same frequency and phase. Next one is non-coherent. In non-coherent digital modulation technique, there is no requirement of reference waves. Impact of GMSK in 2G. GMSK stands for Gaussian Minimum Shift Keying. GMSK modulation, a form of continuous phase frequency shift keying, was widely used in 2G GMS networks for efficient data transmission. GMSK's constant envelope property and spectral efficiency made it suitable for mobile communications applications with limited power and bandwidth. The use of Gaussian minimum shift keying modulation in 2G networks contributed to the widespread adoption of mobile phones and the growth of wireless communication globally. Adaptive modulation in 2G. Adaptive modulation techniques were introduced in 2G to dynamically adjust modulation schemes based on channel condition and signal quality. Adaptive modulation improved the reliability and performance of wireless communication in varying environments, leading to better user experience. The implementations of adaptive modulation in 2G networks showcased the importance of flexibility and adaptability in optimizing wireless systems performance. Digital modulation techniques is coherent and non-coherent. In the coherent, we can see the phase shift keying, frequency shift keying, amplitude shift keying, continuous phase modulation, and hybrids. In the non-coherent, FSK, ASK, differential phase shift keying, CPM, hybrids. FSK stands for frequency shift keying, ASK stands for amplitude shift keying. Non-coherent detection requires no reference wave. Coherent detection process received signal with a local carrier of same frequency. Role of modulation techniques in spectrum efficiency. Modulation techniques play a crucial role in optimizing spectrum efficiency by maximizing the data throughput within the available frequency spectrum. Efficient modulation schemes like QPSK and quadrature amplitude modulation. QPSK stands for quadrature phase shift keying. QAM stands for quadrature amplitude modulation, enable higher data rates while minimizing the spectral bandwidth required. Improvements in spectrum efficiency through advanced modulation techniques have enabled the evolution of wireless communication towards higher generations with enhanced capabilities. Importance of error correction in modulation. Error correction techniques integrated into modulation schemes help mitigate signal distortion and improve the reliability of data transmission. Forward error correction (FEC) and interleaving are commonly used in conjunction with modulation techniques to enhance error resilience in wireless networks. Robust error correction mechanisms contribute to the overall quality of service in wireless communication systems, ensuring seamless connectivity. In this slide, we can see the future trends in modulation for 5G and beyond. With the advent of 5G and future wireless technologies, advanced modulation techniques such as orthogonal frequency division multiplexing and 64 QAM are being deployed. These modulation schemes offer higher spectral efficiency, increased data rates, and improved performance in dense urban environments with high user demand. The evolution of modulation techniques continues to drive innovations in wireless communication, laying the foundation for the next generation of ultra-fast, low-latency connectivity. This is last part of the topic is conclusion. Modulation techniques have played a pivotal role in the evolution of wireless communication from 1G to 5G and beyond, enabling higher data rates, improved spectral efficiency, and enhanced user experiences. The transition from analog to digital modulation in 5G marked a significant milestones in the development of wireless networks, setting the stage for modern mobile communication services. As wireless technologies continue to advance, ongoing research and innovations in modulation techniques will shape the future of wireless communication, unlocking new possibilities for the communications. Thank you.